proportions, if that name kind of triggers a bell at all. Does anyone remember what we need to do with something like this? Guys, make sure mask up, please. Yeah.
Yesterday, science.
You did in science.
You needed this in science.
Oh, cool. So that helps.
You taught us the fish method.
What's that?
The 4 times 10 to the 1 is 6 times that.
Yeah. Why is he called the fish method? I don't know.
Because it's more fish.
Because like you, I see, like this, like that. Oh, I see. Okay, I've never heard that. Okay, so I just, I always, anytime students do this, they always like to circle things. So cross multiply. So cross multiply, I guess if you heard fish method works as well. So yeah, like kind of getting the idea that sometimes stuff comes across different curriculums. So both science and math use this. I would imagine like maybe in like physics or some of the other areas of science you might use it as well. So we cross multiply and then we set those two equal to each other. So x times 6 is 6x. 4 times a negative 11. Now this one's going to be a fraction or a decimal. It's okay. Sometimes we want it to work out to be a really nice number. Not always. Divide by 6. And that is going to be a negative 7.333, repeating on Trevor. Or negative 22 over 3, negative 7 and 1/3. Lots of different ways you can write it. So number 2 there is a little bit more complicated because there's x's on both parts. We can still use that same method. We're going to cross multiply. But this time when we do this, we have to remember that we want to multiply the 4 times both the x and the 3. And then 1 times 3x. So I want to use parentheses in this case to make sure I remember to distribute that 4 into both parts. And distribute here. And so I'm going to bring the x's together, so I'm actually going to move that 4x over. And then we'll divide by a negative 1. So x ends up being 12. So we'll use proportions a lot this chapter. So this is like, again, something you guys learned in algebra. You probably even learned it maybe in pre-algebra or middle school math. And then it's something we keep using again and again in this section and geometry. It's used quite a bit. So we're going to talk about ratios, which you probably learned a little bit before, proportions, and then something called the geometric mean, which will show up at the end of this section. So first start off by talking about ratios. So the ratio is basically a comparison of 2 or more values. Now, you probably use ratios all the time without even realizing it. If you like sports statistics, you use ratios all the time. The number of times someone gets a hit versus the number of times they were at bat. Free throw percentage. But even like shopping, like, and, you know, if I'm trying to buy something and figure out the price, you know, how many like ounces I get for how much money, that's a ratio. That's comparing two values. And even just your grade today in your test. So like Stone was figuring out his percentage. That's just a ratio of values. It's the number correct compared to how many total problems there were. So ratios show up everywhere. Now, you can write ratios a few different ways. So the way you see them often is like a number over another number. So, you know, like you got a 50 out of 53 on the test. You can also write it as using like a little colon. So you see that sometimes in statistics. Or even something like that. So they're asking us to simplify these ratios to compare these two values. But if you look, they start off with the same units, yards and yards. Here they switch the units, so we'll talk about that. We had a problem pretty recently about that, where you had to switch from like feet to inches. So we have 24 yards to 3 yards. And that's as simple as they're kind of saying there. 24 yards to 3 yards. Now yards immediately, I'm a sports person, so I think about football. So, I mean, maybe if you're playing in a football game and one team got 24 yards for the other team every time they only got 3 yards on their drive or whatever it happens to be. I just think one team is doing better than the other. We can just simplify that then. The 24 over 3 is just what? When I simplify 24 over 3? 8 over 1. So it'd be 8 yards to 1 yard. So every time the one team got 8 yards, the other one only got 1 yard. That ratio of values. Now this next one is comparing feet and inches. We can't compare feet and inches, they're not the same units. So you may have to switch something over to a unit that makes more sense for us. So what do you want to switch feet or inches to? Like which would you want to go? Which one makes more sense to switch? Yeah. Yeah, let's switch the 5 feet to inches. So 5 feet becomes how many inches? 60, it's times 12. If you're 5 feet tall, you're 60 inches, and anything over that, you just add the inches on there. So 60 inches to 20 inches, so then we just simplify that. That'd be 3 inches or 3 inches to 1 inch. So pretty straightforward there, nothing too difficult. So then they ask us about equivalent ratios, or they talk about equivalent ratios. And so those are basically ratios. Equivalent means equal. So ratios that are equal. They'll use that term from time to time here. So equivalent ratios, so kind of similar to what we just showed up there. It's 2 ratios. So we just showed one up at the top. So 60 over 20 is the same thing as 3 over 1. Those are considered equivalent ratios. But it can also work another way. So if I have 1/4, what's an equivalent ratio to 1/4? Yeah. What's that? 8. 8 and 32, okay. So you multiply each of those by 8. Somebody else give me another equivalent ratio. 1/4 or 8 over 32, they're the same. 5 over 20. So looking quickly, you might see these and be like, oh, that's not the same value, but they're really talking about the same value there. So just that you know, those ratios are all the same. Now, typically we want to write it usually in simplest form. So like this one to me looks the most appealing, but there's going to be times it makes sense to use some of the other ratios as well. Okay? So it says write the ratio of the width to the length in simplest form. So we're comparing the width to the length. So it's saying to do width over length. Now, for argument's sake, what do you guys want to call the width? Like going across or up and down? What makes more sense? Width versus length, what do you guys think? What do you think this one is? Width, and then length would be across. That's fine with me. It's gotta be just consistent, I guess. So length is this way, and then width would be here. So they want it in simplest form, so width to length, so 12 centimeters to 18 centimeters, and then we just simplify it. Can I divide both of those by? 6. So 2 centimeters to 3 centimeters. So every 2 centimeters on the width, it's going to be 3 centimeters on the length. That's going to be the ratio of the side lengths there. Now, the issue with letter B is they're not the same units. Now, there's going to be times that you might have to either look up or try to do that conversion. Do you know about centimeters to meters? Anyone know? The name kind of gives it away. Centimeter, the word centimeter. Centi is century, so it's 100 in a meter. So there's 100 centimeters in 1 meter. So if you think about like a meter stick, which I have in the closet here, a meter stick is, if you look, it has 100 centimeters on it. So all the way across there. So we could change either one. I think changing the bigger one to the smaller one is a little bit easier. So if we have 1.5 meters, how many centimeters is that going to be? 1.5 meters to centimeters?
150.
150, thanks. So it's 150 centimeters compared to 1.5 meters. So they're doing width to length. Now, anytime they both have zeros, I just divide by 10. You get 15 centimeters over 52. Now that seems like something you should be able to divide out of that, but 52 is not divisible by 3. So I think that's it. So there's a lot of different topics in this section, so I apologize. We will take a break about halfway through. But so all these different ratios have kind of different rules that go with them. So make sure you guys are taking good notes, because when you go to your homework and they're like, talk about this extended ratios in a second, I wouldn't know what that is unless I was, in a geometry class. Extended ratios, that doesn't make any sense to me, but we'll explain it here. So every problem that's in your homework, there'll be a similar example that we're doing here. So, I don't have room. All right, so extended ratios. And basically that means there's more than 2 values in our extended ratio. So it could be like A to B to C now even. There could be another value that we're comparing. Okay, so it says, in a triangle, the ratio of the measures of the sides is 3 to 3 to 8. The perimeter is 392 inches. Find the length of each side. So a triangle, I'm going to draw. So the ratios is 3 to 3 to 8. So this is talking about sides. So I'm going to call this 3, and this 8. That makes sense. But then it tells me the perimeter is 392 inches. First of all, perimeter means what again? All the way around. So the distance around should be 392. Right now, ours adds up to 14. That's not enough. But this is the ratio. So this is basically saying that 3 to 3 to 8, that's the ratio of those sides. But just like we did with equivalent ratios, I could double those numbers, I could triple those numbers. Whatever I do though, I have to multiply them all by the same value. So whatever I do to them, they have to all be doubled by the same value or tripled or, whatever it happens to be. So I'm gonna put X's here. Because they're all gonna get multiplied by the same value in order to find that next equivalent ratio. I know these should add up to 392. So we're gonna take these and add them. And it should add up to 392. Like I said, we have 14, but it's 14x. We're trying to figure out the value they were all multiplied by. So x ends up being 28, is that right? Now that's not the length of each side. That's the value we're going to multiply all those ratios by, all those side lengths. So this is going to go in then, so it's going to be 3 times 28, which is 3 times 28, 84. So this is going to be 84. This obviously is 84 as well, and then 24. Now this is a really bad problem. I'll tell you why in a second. Maybe you realize it. We just finished a chapter on what triangles need to be. What's my issue with this problem? Anyone see it? Yeah, this is a bad problem because that shouldn't even be the side lengths of a triangle. 84 and 84 isn't big enough to add up to 224. So this is a really bad example because it shouldn't even really form a triangle. But, I should just change the numbers and make it better, but I keep forgetting to do it. So it's not a great example probably in our chapter we just did. We're going to do the same things with angle measures. So it says the ratios of measures of 3 angles in a triangle is 3 to 6 to 1. So we draw a triangle. So 3 to 6 to 1. Talking about angle measures. Well, obviously those aren't the angle measures of a triangle. So just like we did in the last problem, I can give them all an x. I can multiply them all by the same value. What do I know about the angles of a triangle? Yeah. Yeah, so we're going to add this together to make it equal 180. So that ends up being 10x. X is 18. That's our first angle, 18 degrees. This one times 3, that'll give us 54. And then this one I believe is 104. 108, sorry. I get for 20. So we have our 3 angles of our triangle. All right, why don't we stop for a bit here? Why don't we grab, these two want to grab marker boards, markers, erasers over here. Next middle two, want to go? And the last two, I have you ready. Draw a hand turkey. Did we do a hand turkey already?
Just get extra on your own.
Dividing big numbers. All right. Look at Mickey Mouse.
Yeah.
All right, so I'm going to give you guys some ratios here. We'll work on. Well, actually, let's do a proportion. Let's do a couple of proportion problems. So I want you guys to solve for x. Forgot that we did that at the start here. So x over 14, x over 14 equals 6 over 21. Yes, good job. Yes, good job. Yes, good job. Yes, good work. Yes. Yes. Yep, good job. Yes. Yes, yes. You're done. Yes, good job. Yeah, you might want a calculator handy in case your long division skills are a little rocky or whatever. So we cross multiply and set equal. So I get 21x equals 14 times 6. So 21x, and I believe this is 84. Divide by 21, and we find out x has to be 4. Okay. A few more proportion here. So you guys want to solve for x here. Yes, good job. Yes, 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 yes. I have such a hard time not writing these down. Like I want to work them out. Yeah, you guys got them. But then I'm like, okay. So we cross multiply. So that just gives 2x plus 1. And that's going to equal this 21. We're going to set that equal to 2x plus 1. And then we're going to move this guy over. So we just move that over. Yes, you got it. Yes, yes. So yeah, and then so this will be gone. Then so we move our guys.
Well, everyone
And then the absolute divide each divide.
Yeah. Everyone.
Yeah. Yeah, that's it.
So we're
So we cross multiply, move the 1 over, 2x equals 20, divide by 2, so x ends up being 10 in this case. All right, let me give you guys a little bit trickier one here. There you go. I was like, okay, yes. Okay, let's see any of it. Well, the only thing that should be a negative. Yes, 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 yep, yep, yeah. Yeah,
I'm really not.
so on this one, you guys, that negative makes this 6 negative, so the -6, but then in this case, you have to use parentheses, because I have to multiply that 3 by the x and the 1. So I have to distribute that in. So then we have to solve this. And I will tell you guys, I can show some of you guys, or show you this and see if this only works on some types of problems. But x ends up being -10. Now the way I did this problem was I just simplified this. 6 over 3 is just 2. And then this divided by -1. So then I just solved that. So there are sometimes like little shortcuts with these proportions, but this is kind of the fail-safe way, like doing kind of all those steps. But it works either way. So if you know a shortcut or notice a shortcut, you're welcome to try it or use it. All right, let's try another proportion and then we'll do some ratios. Oh, sorry, solve for A instead of X. Distribute. 6 times 3. Right? Yeah, okay, I was like, 2A is 2, but then 2 times 1 should be 2 here. You guys are making me nervous because like you did a past, yes, no. So, move this over, and then move that over positive 18. Yeah. Yes. Yep. Yeah, better here. Back somewhere to the numbers. The 4x needs a 2 behind it. So if you distribute that 2 in, the 2 times the 2a is 4a, and then minus 2. Yeah, you're good. Thank you. Yes, good job. Yeah, a few places to make little mistakes here. So, in this one, we have 6 times a minus 3, and then 2 times 2a minus 1. And I know a lot of you guys want to go fast, and that's perfectly fine, because I try to do a lot of stuff quickly in my head, but I do make mistakes that way. And so this is 4a minus 2, which I saw some of you guys go wrong on either side of that. Now we want to bring the 4a over. So this is 2a minus 18 equals a -2. We're going to add 18. So 2a equals 16, and that's how we end up with 8. Okay. So I'm going to move away from proportions, and we'll do a couple of ratios. It's like the extended ratios. ratio of the angles of a triangle. And you want to find, I want to find all three angles though, so yes, that's right. But then you want to go ahead and find all the angles. I need to write them down. Yes, there you go, yes, yes. I think your first one's wrong. There you go. Same multiplication. Yes, you got it. So this, yeah, if you have an example like this one, you're good. I think, yeah, you're kind of just like, yeah. Yeah. Okay, so once you find x, then you have to go ahead and put that in. So you add these three together. This is similar to what we did right here. We're gonna add these three together and we get 20. And they all kind of have like an x behind them, so it's like 20x. And we know it has to equal 180. You're right about the 180 part. Yep. So you're right. Add them all up and they equal 180 here. Yeah, sorry. Yes. 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 Equals 180. What? Then you can solve for x. Divide by. What's it? Yeah, so this is being multiplied by 20, so we're gonna divide by 20 instead. Yeah. So that'll give you, so your x is 9, so then you're gonna put 9 back into all of these. So you divide by 20, and that'll be all your So, okay guys, so when it's talking about ratios of angles, I know the angles should all add to 180. And then, so this is gonna be 20x equals 180. And we find out x has to be 9. Once I know x is 9, then I have to go and find all those angles. So I'm doing 5 times 9 is 45. 9 times 9 is 81, and then 6 times 9 is gonna be 54. So the way to check that we did this correctly is they should add up to 180. Let me grab one more with side lengths though. I want to make sure I have one that works. Oh, maybe they don't. Hang on, just let me. Okay, so this next one, we're talking about side lengths. So the perimeter of a shape, perimeter of a triangle is 76. The ratio of the side lengths is 5 to 6 to 8. Tell me all the sides. So give us the perimeter, 76. Ratio of the sides is 5 to 6 to 8. And then I want to know the sides. Yep, yep. Yes. Yes, yeah. Something went wrong. Try You're good, yeah, you're good. Yeah, Abby, you're good. Yep, sit down. Yes. And then once you know X, then you have to go and find the side length. So that's not actually the side length. Yes. So this time, these are the side lengths. So those should add up to equal 76 this time. They have to give us that perimeter. So 6x plus 5x plus 8x equals 76. So this will be 19x equals 76. So we find out x is 4. Once I know x is 4, I have to put that back in. So my side lengths would be 20, 5 times 4, 24, and then 32. All right, so we can clean up boards. So if the middle group wants to take theirs back. Hello, thanks for that video. I think so. Yeah. We need to figure out a way how to add music to it. You guys over here, take yours back. Or like the Grinch music, like when he's like faking his costume. We're sneaking and sneaking. Alright, and last group then. On the front. Nice. Alright, so we're talking about something again. This is something that's not a complicated topic, but unless someone tells you what it means, it doesn't really make a lot of sense. So the word the term geometric mean. Now, we use a mean in algebra. A mean is just the average of the numbers. Geometric mean is a little bit different. It's like they came up with their own things with their geometry. So what the geometric mean looks like is basically a proportion. So A over B equals C over D of the geometric mean. Now, if I was doing that, kind of using that idea of the cross multiplying, I would say that AD equals BC. That's just in general. And they call something called the means are the B and C, and then something called the extremes is A and D. Now we're only going to use the positive geometric mean. We don't really have to worry about negatives too much. I don't know why, sorry, I might have to change something. The mean actually should just be a single value. I don't know why I have two values for it. So can you change B and C? Does anyone, do you guys have erasers? Sorry. Sorry. We call that X. Sorry. So, I don't know why I have that problem there. So if I multiply X times X together, what do I get? X times x is gonna be x squared. Well, that should be 18. Oh gosh, all right. So in order to figure out what x is, we're gonna take the square root of each side. I'll show you guys how this looks. Sorry, a little bit jumbled here. So the geometric mean between these two numbers. So that what this means is these are the extremes. So I'm going to tell you guys to put those on opposite parts of the fractions. So we're going to make this proportion, and the 4 and 25 are going to go diagonally from each other. And it doesn't matter if you go upper left, lower right, or vice versa. Then the geometric mean I'm going to call x. I'm going to write x and x across from each other. So in order to solve this, we're going to cross multiply, or apparently do the fish method. I didn't know they called this the fish method, Miss Miller. Yeah. Oh, I never heard that. This is the fish method. So x times x is x squared. 4 times 25. 4 times 25. 100, thank you. So in order to solve for x, we're going to have to take the square root. This might be a button in your calculator you haven't used very often. The square root of 100, 10. And that might be one you don't even need to know or check. You just know. Now, technically, there should be two answers there. There should be a positive and negative 10, but with geometry, you only deal with that positive version in this case. So try setting up this one. So again, they're giving us the extremes, 6 and 20, and you're trying to find the geometric mean. So you're trying to find x. I'm going to start by setting this up. You put those extremes across from each other, and then the x's go the other diagonal. Six times 20 is going to be 120. Now this is one that off the top of your head, you're probably not going to get. It's like 10 point something. So the square root button is usually above the squared key on your calculator. So if you don't know where that is, you might want to locate that. I take the square root of each of these, and it's going to be about, like I said, I know it's more than 10. It's a little less than 11. 10.95. That's our geometric mean. Chicken monster. Alright, so the next type of problem here says the ratio of two complementary angles is 2 to 7. Find the angles. What do we know about complementary angles? What's that? 180 or 90. Complementary is the ones that add up to 90. Okay, it's been a little while. No, maybe that's what she said. But they add up to 90. So complementary angles, we have 2 and we have 7. Obviously, that's not the angle measure. This is the ratio. What are we going to do with the 2 and 7? What do we need to, else do we need to do with them? Put an x with them, yeah. So 2x and 7x should add up to what? Should add up to 90 because they're complementary. So 9x equals 90. So x ends up being 10. And then we can find those values. So the two angles would be 2 times 10, which is 20, and then 70 as well. Okay. Now, had it been supplementary, it'd be 180. All right, so flip your page here. There's like 3 more examples, and we're almost done. Nothing too crazy here still. Like I said, there's a lot of different types of problems in this section. So just like using your notes to help you as you go through your homework. Don't like run into a problem and say, oh, I don't remember how to do that. I mean, we do examples so that when you get home, you can say, oh, that's what we did there. So this one, they tell us X and Y, and they want us to figure out the ratio in simplest form. What do you think we're gonna do with that? So Ellen, what are you doing?
I'm putting whatever into
Yep, so she's putting them in. So 2 times 9 minus 4 over 9 minus 4. So she's substituting them in. We're going to figure out what that is and see if we can simplify. I actually don't think you have to simplify it. I think it just is simplified. So 14 over 5, that's the ratio in simplest form. She's asking for a fraction in simplest form. Now, we did a bunch of ratios with 3 side lengths. This time, they're only telling us 2. They say the ratio of 2 side lengths is of the triangles given. Solve for the variable. So you might think, well, I want to add these 2 together, and they should equal something, but they don't because we don't know that third side. So what we can do, the fact that they tell us a ratio is really helpful. So ratio makes me think fraction. So I'm going to write 5 over 2 as a fraction. 5 over 2 as, instead of as like the little colons. What am I going to write in my other fraction? Yeah. What's that?
10 over 4.
Oh, you could do that. I'm going to wait on yours because I'll show you your method here in a second. That's good though. Yeah.
1 plus 3x.
Yeah, so what I'm trying to point out, and like what you do, it actually makes sense. A of B is this one, and that's 5. So this is going to go in the same position as the 5. AB over BC. And then BC is 4. Now how are we going to solve something like this? What can we do here?
Cross multiply.
Cross multiply. And I'll talk about what Drake said in here in a second. So I'm going to do 2 times 1 plus 3x equals 25, or 20, sorry. X ends up being 3, and that's all they needed us to do. Now, I'm going to mention what Drake said there. He said 5 over 2 is the same thing as 10 over 4. Worked out pretty nicely in this case. So he's saying that equals 10 over 4, but he also knows that equals 1 plus 3x over 4. So what he could have actually done at this point is he could have just solved this top part. If they both equal 4 on the bottom, you could set that equal. He would get 3, maybe a few steps quicker than us, but it's whatever you notice first. So there's kind of cool things that happen with ratios, and that was an example of one that would work nicely. I just don't know that that would always work. Like the numbers weren't going to be a nice whole number. That little trick wouldn't work for every situation. So it works nicely in some like times, but not always. All right, last one here. So it says the diagram, the ratio of AB to BC is 3 to 8. So this is 3 and this is 8. AC equals 44. Find the length of each of those. Obviously, they don't equal 3 and 8. Because 3 plus 8 does not equal 44. But if it's a ratio, again, 3x, 8x, I know they should equal 88 together, so I'm just going to add them and set them equal 44 together. Set them equal to 44. And then that would allow me to figure out AB is 12 and BC is 32. Is that okay? Now, in your homework tonight, you might want a few different conversions. Now, there's a great thing called the internet. You can always feel free to look up conversions. If you would ever need a conversion, like on a test, I would give it to you. But like if you don't feel like looking them out, like there's 16 ounces in a pound. I'll write down some of the ones you might need. 1,000 milliliters in a liter. 5,280 feet in a mile. We did the 1,000 centimeters in a meter, and then 12 inches in a foot. So those might be helpful